Okay, YouTube, this is my second video in my module on lines and their slopes, in which we're going to confront how to write the equations of a line. And really, there's just one primary way that we kind of hold on to write the equation of a line. And the way we develop it really is just from our slope formula. So we have our slope formula from our last video here, which is change in y over change in x. And the way we develop this point slope form is what we're going to call it to write the equation of a line is basically what we're going to do is instead of y2 minus y1 over x2 minus x1 equaling our slope, we're just going to leave one xy arbitrary. It could represent any point on the graph here, but we're going to allow y1 and x1 to represent some other point on the graph there. So basically, when you look at this image over here, we could say that there is some fixed point on the line, and we're going to refer to this as x1, y1. So in order to use this point slope form, we're going to need to know this fixed point. And then this other point on the line is arbitrary. We're just going to let it be some other point on the line, and we're not going to assign it values. We're just going to leave it as x, y. But using our very same slope formula, the same one that you see right here, essentially what we could do is you can see that multiplying both sides by x minus x1, where we're leaving x2 arbitrary in this case, it would eliminate itself on this side of the equation. What we get left with is this thing right here. And basically what I can tell you is this is referred to as the point slope form of a line. So we're just going to read this right here. It says the point slope form of the equation of a non-vertical line with a slope of m that passes through the point x1, y1 is essentially this line right here. So here's what I'm going to tell you. If you ever want to write the equation of a line, you need two things. You need a point. We're going to call this point x1, y1. And we need the slope. We just need these two things. And what we're going to do is we're actually going to go plug x1 and y1 in for their values in this formula here, and then plug m in for this value right here while leaving this x and this y arbitrary. And then we're going to just basically solve for y, and we'll have the equation of this line. So to practice this, what I would like to do is this. We're going to do this twice now. But I pasted this in here, the point slope form of the equation of a line, which is this y minus y1 equals m times x minus x1. But I want to use this time to write the equation of a line, say, for example, on checkpoint 2, in point slope form for the line with a slope of 6. So we have a slope of 6 here. I'm going to write that down. I already know my slope. It's one of the two things I need. And it passes through the point 2 comma negative 5. So again, we also need a point. So we now know this x1, y1. And then what we're going to do is we're going to solve the equation for y. So using our point slope form, which is this y minus y1, equals our slope m times x minus x1, all we're going to do is we're going to substitute for the values y1 and x1 and m. So we have y minus y1 equals the slope m times x minus x1 here, where what we have for x1 is a value of 2, and an output value of y is negative 5 here. We're going to put that in with parentheses. And then our slope, we desire to have a slope of 6. So first things first, I'm going to put a box around this because I want to indicate that this is the point slope form of this line. And it is really the equation of the line at this point. It's just that often what we like to do is we like to isolate the y value. So I'm going to rewrite this equation here. We have y plus a 5 really times 6 times x minus 2. To finish this off, to isolate y, we're basically going to distribute on the right side. We're going to simplify both sides. We get y plus 5 equals 6x minus 12. And then what we're going to do is, well, we would subtract 5 from both sides in this case. And then we would say, well, I have this isolated now. And the equation of the line in what we call slope-intercept form, which is in a future video here, is this right here. So here's the equation of our line, not in point-slope form, but in slope-intercept form. So looking at example number 3, it says, write an equation in point-slope form. So we're still using point-slope form. But for the line passing through the points negative 2, negative 1, and negative 1, negative 6, and then solve the equation for y. So again, we're doing the same thing here. The real question becomes this. What is our x1 and our y1 going to be, and what is our slope? We need these two things. So in terms of x1, y1, here's the cool thing about it. x1, y1 represents some fixed point on the graph, and I could use either of these points. I just need one of the points on our graph. So because just the magnitude of the values in negative 2, negative 1 are a little bit less than negative 1, negative 6, I'm going to use this as my x1, y1. Now as far as the slope is concerned, this is something that we still haven't determined. So we're actually going to need to go find it. So we say the slope is our change in y over change in x. So we would have change in y. So we'd have negative 6 for our y2 minus y1 of negative 1. And then negative 1 for our x2 minus x1, which is our negative 2 here. So I'm going to switch these over here, and we'll get a value for our slope. And it turns out that we get, looks like a negative 5 on top. And on bottom looks like we get a negative 1 plus a positive 2, which would make this a positive 1. So our slope must be negative 5. So the good news is now we have a slope, and we have x1 and y1. So we're going to go write this equation here where we have y minus y1 equals our slope times x minus x1, where excuse me, our y value of our point here is -1 if and only if the x value at the same time is equal to -2. And we were able to determine that the slope of this line is -5. So just as we did in the last example here, what we're going to do is simplify both sides. We're going to clean this up by making that a +1, and then we're also going to distribute our -5, which makes this -5x. And this will be a plus a +2, but when taken times a -5, make this a -10. So now we're just going to subtract 1 from both sides, and we should have the equation of this line in slope-intercept form, which will be introduced next. But anyways, here's the equation of our line, and that is as easy as it is to write the equation of a line. Cheers.